So today we're going to look at division of polynomials. And we're going to look at two ways to divide. And then after that, we're going to talk about something called the remainder and the factor theorem. Alright, so we're going to start with long division. Now just the word long division probably makes some of you shudder. But let's remind ourselves what we used to do when we would long divide. Let's say we had 728 and we were going to divide it by, I don't know, 31. Alright, so we would say 31 goes into 72 how many times? 2. And then what would we do? We would say 2 times 31 is 62. And then what would we do? Subtract. Okay, so we'd say this goes into this how many times? We put that up there. And we multiply that times that. And then we subtract. And then we get 10. But then what would we do with this 8? We'd drop it down, bring it down. Okay? And now 31 goes into 108 3 times. And so now we multiply. 3 times 31 is 93. And then we would subtract. And this is 5. And this is 1. And this is the remainder. So what we could do is we could take the remainder and put it over the divisor. Do you guys remember long division from 5th grade?
No.
Well, good. I'm glad I reviewed it then. Okay? So it's the same process when we do long division with polynomials. Okay, so I'm going to start with my dividend, what I'm dividing into, and then my divisor, what I'm dividing by. So this problem could have initially looked like this. Okay, and so we would write it like this. Same process though. The exact same process. So what we look at is we look at this. And then we look at this. And we say, how many times does x go into x squared? Or we could word that the other way. The inverse of that. What do I multiply x by to get x squared? X. X times x is x squared. Now, notice where I lined it up. This is an x to the first power. Look what I put it over. An x to the first power. So we want to be careful how we line things up. That gives us clues as to when we're done. Okay? So now, just like this, when I took this times this to get this, I have to take this variable x and multiply by this expression, x plus 2. What is x times x? X squared. What is x times positive 2? Positive 2x. Okay, so just like here, when I multiplied and put the number here, I do the same thing. Multiply and put it here. Now, next here, I subtracted. Guess what I do next here? Subtract. So when I subtract, what's it going to do to all of this? Makes it all the opposite sign. So when we subtract, you need to change everything to the opposite. Okay, so the x squares cancel. That's what we forced to happen. We made that happen. That was our goal. And now what is 7x minus 2x? 5x. And then we're going to bring this positive 10 down, just like we brought the 8 down a minute ago. Yeah.
How did you get that x? The one that's all the way up there.
Okay, so what we said was, what we do every time to start with is we look at the leading here and the leading here. And you can think about it as taking this one and dividing by that one, or the reverse of that. What do I multiply this by to get this? And that's where that original x came from.
And then you multiply x times x and then x plus 2.
Yep. Okay, so now, same process, starts over. What do I multiply this by now to get this? Just like we did over here. Very good. Okay, so we multiply it by a positive 5. So 5 times x is 5x, and 5 times 2 is 10. Okay, then we subtract. So when we subtract, it changes all of the signs. Oh, cancels, cancels.
0.
There's 0. There's no remainder. So instead of having a remainder that we have to write over the divisor, we are done. That's my answer.
And then how do you check your answer?
To check your answer, you would multiply this times this, and it should turn into that. Okay, so let's try another one. Okay, so this is example 2, I guess, really? All right, we're going to have 2x to the third. Oh, Moby. Minus 3x squared minus 10x plus 7. So this time we have a longer one. Divided by, so I'm going to show division a different way with a big fraction bar, x minus 3. Okay, so the first thing we set it up is old-fashioned division way. The dividend, what we're dividing into, goes under. The divisor, what we're dividing by, comes out here. All right, this and this. What do you multiply x by to get 2x cubed? 2x squared. 2x squared. So I'm going to line it up above the square. All right, so 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 3x squared.
Wouldn't it be negative 6 instead of 3?
Yeah, it is, thank you. Negative 6x squared.
Can you do that then?
Okay, so now we got to change our signs because we're subtracting. When we subtract, we change our signs. Okay, so these cancel, and then negative 3 and positive 6 is positive 3x squared. Then we bring it down. I multiply this by to get this now? What do I multiply x by to get 3x squared?
3x.
3x. And it's a positive 3x. So the 3x has to get multiplied by both of those. So we get 3x squared and then negative 9x. And then we subtract, which changes all of our signs. And we're left with negative x, bring it down, plus 7. All right, what do I multiply x by to get negative x?
1.
Negative 1. So a negative 1 times this stuff is just going to change the signs. And then we subtract. So when we subtract, subtracting this from this makes this turn to positive, this turns to negative. So this time, I've got a remainder. I'm out. I filled up all of this. So what's left down here is now the remainder. So the way we write the remainder is we write the remainder over the divisor. And this is our answer. So that is long division of polynomials. So you have a little practice with this. Long division is usually my last choice. I will try to factor and cancel before I do long division. I will try what I'm about to show you, synthetic division. For me, long division is my last choice. There's a lot of work here in there. Yeah. So sometimes it's the only way to divide. So it's a good tool to have because sometimes it's the only thing that works. Okay? But there is a shortcut. And our shortcut is using synthetic division. And we're about to do the same problem with synthetic division. We got some rules with synthetic division though. Okay, we can use synthetic division with polynomials. And here's the rule we use in here. If the divisor is a linear binomial, we're going to talk about what this means, remind you what linear means. And we only use it in here when that linear binomial has a leading coefficient of 1. With a leading coefficient of 1. Okay, now truly, if the divisor is a linear binomial, you can do synthetic. It doesn't have to have a leading coefficient of 1. But we've noticed over the years that if you guys try to do fractions, sometimes our math gets ugly. So we're going to stick with synthetic division if your divisor is a linear binomial with a leading coefficient of 1. So what does that mean? Well, it could look like the ones we've already done. That's a binomial, isn't it? The x is to the first power, and it's an understood 1. This is a linear binomial with a leading coefficient of 1. X minus 5. That is a linear binomial with a leading coefficient of 1. So if these were your divisors, you could use synthetic division. And you probably should. Synthetic division is a nice shortcut. Okay, so I'm going to work the exact same problem we just did, but with synthetic division. So, oops, where'd it go? It disappeared.
Oh, it did.
My last example. All right, I'll write it down again. Okay, so it was 3x cubed it was 2x cubed minus 3x squared minus 10x plus 7, all divided by x minus 3. Okay, so this is the example we just did, but now we're going to learn, because these were our examples of linear binomial, does that look like a linear binomial with a leading coefficient of 1? All right, so here are your steps. Looks weird, really nice shortcut though. Okay. I call that a table. I have no idea why. It doesn't look like a table. Yeah. You sure can. All right, so what would make this factor 0? What can I plug in here for x that would make that factor 0? Anybody know?
Positive 3.
3. Okay, so what happens is, because we want what makes this factor 0, and this is our rule, it always ends up being the opposite of this. Just like the x-intercept was always the opposite of the factor, this is going to be the opposite right here. And then what we do is we take our coefficients of our dividend, what we're dividing into. So the divisor goes here, the coefficients, and the constant of the dividend there. All right, and then mathematically there's a lot of reasons why this works, but it's really cool how neat and orderly it is. Okay, what you do is every time, whatever this is, we bring it down. No matter what this leading coefficient is, it gets brought down every time. And then we multiply what's on the table times this coefficient we just brought down. So 3 times 2 is 6. And then we add. Negative 3 plus 6 is 3. And then we multiply. 3 times 3 is 9. And then we add. Negative 10 plus 9 is negative 1. And then we multiply. 3 times negative 1 is negative 3. And then we add. And we get 4. Now, if you go back and look at the problem we just did, do you see a 4 somewhere, a negative 1 somewhere, a 3 somewhere, and a 2 somewhere?
No.
Aren't those the exact same things we got when we did long division? Yeah. So this last part will always be the remainder. So when you're writing your answer, that remainder always goes over your divisor. And then we work our way back. Going this way, this next was our constant, just a plain old number. This turns out to be the linear term. And this one is the quadratic. So we work our way this way. And because this is a positive 3, we're going to put a plus sign. And that's the same answer we just got a second ago with all that work. Okay, so here's your U-track.
We have to do it this way.
I would like you to do synthetic division. Synthetic division. So we're going to have x cubed plus 5x squared plus 2x minus 8 divided by x plus 2. Okay, so step 1 is to decide what goes on the table. Because we're dividing by x plus 2, the opposite sign goes on the table. Then we pull all of our coefficients in order. Now, one thing you do have to watch out for that this problem didn't have, if it's missing any degrees along the way, let's say it was missing the x squared, we would have to put in a 0 for any missing degrees. This one didn't have any, but it could definitely happen. Okay, so the process is bring down the first one every time. Multiply, add. Multiply, add. Multiply, add. Now, this time we got a remainder of 0. So when I work my way back, this is my plain old number. This would have the x, and this would have the x squared. So this becomes x squared. This is a positive 3x and a minus 4. You know, whenever it has a remainder of 0, what that tells me is that the divisor is a factor of the dividend. Whenever the remainder is 0, whenever we get a 0 for a remainder, that tells us that the divisor, what we're dividing by, is a factor of the dividend, what we're dividing into.
What happens to the x cubed?
Okay, because I took an x cubed and divided by an x, it goes down to a square. Okay, so the middle section of your homework is this. All right? The top section of your homework is the long division. I am going to do one of each of these problems with you, and we're going to save the factor theorem and remainder theorems, talk specifically about those two things tomorrow. Tomorrow's lesson isn't as long, and you need practice with what we're doing today. So I'm going to pass out tonight's homework, and we're going to do 2 of these together, one of each kind, and I'm going to pick the strange ones, okay? Okay, so tonight's homework is the odds on this sheet, and the evens are due Tuesday.
Odds are due what?
The odds are due tomorrow, and the evens are due Tuesday.
Do we have more homework tomorrow?
Yeah.
So this and the other thing tomorrow? Oh, Tuesday.
Okay. All right. Number 5 looks the most convoluted to me up top. So we'll do number 5 together. So the top part asks you to do it with long division. So we're going to do number 5 together. And number 5 is this problem. X cubed plus 3x squared minus x minus 3 divided by x squared plus 4x plus 3.
Can you show me the work on different?
I definitely would. There's no room on the sheet of paper. I would definitely show my work on another sheet of paper. All right. So this is a good problem for long division instead of synthetic, because if we look at this, the divisor is not a linear binomial with a leading coefficient of 1. This is a trinomial. So it's quadratic trinomial. So my divisor makes me want to try long division on this problem. So when I set up long division, the divisor goes out here, and the dividend goes under here.
Is it going to be like this when we have to do synthetic division on one part and then we have to do long division?
Yes, ma'am. Yeah. We're actually going to do a good bit of synthetic division. Synthetic division lends itself well to everything we do for the rest of the unit. Long division isn't as helpful. So we'll practice it so that we acquire that skill, but it's not going to help us as much with our polynomial functions we're looking at. All right, so we look at this, x squared, and we look at this, x cubed. What do you have to multiply x squared by to turn it into x cubed? Just an x.
Why do you put it like over there?
I line it up with the same degree. So just an x is the first degree. I put it over the first degree.
So
All
is
right.
that always going to be one like that? Like where it's always the same?
Okay, if there's not one, like if this were missing an x, I would put 0x in here when I wrote it.
Oh, yeah.
So if there's not one, I make it show up. So x times all of this. Well, if you distribute an x, it just makes each of these x's go up 1 degree, right? So x times x squared, x cubed. X times 4x, 4x squared. X times 3, now we got a 3x. So you take this and distribute through. And what do we do now? Subtract. So subtraction changes all of my signs. Now, every time this first one's going to cancel, because that's what we're forcing to happen. So when it does, we should be happy. Then this gives us negative x squared, negative x to the 4th, and then we bring down. Okay, now what do I multiply x squared by to get negative x squared? A negative 1. So negative 1 times all this stuff is just going to change some signs. Negative x squared, negative 4x, negative 3. And now when we subtract, what does it do to every sign in this trinomial? Changes it to the opposite and cancels, cancels, cancels. Woohoo! No remainder. So when I have no remainder, what does it tell me about this quotient? It is this was a factor. Correct. It is a factor. Okay, so the next one I'm going to pick is on the synthetic part, which is the middle part. And I'm going to do number 15. All right, this is a great synthetic division problem because the divisor is a linear binomial with a leading coefficient of 1. So this is the problem, x cubed plus 5x squared minus 18 divided by x plus 3. I chose this one on purpose because it's missing the plain old x. It's missing the x to the first power. So I wanted you to see what happens when it's missing one. All right, so if my divisor is x plus 3, what goes on the table for synthetic division? Negative 3, the opposite. Very good. Now, I pull down the coefficients. Understood 1, then 5. But, guys, because there's no x, a 0, tried to change the color, a 0 goes right here for the x. And then negative 18. So because it's missing the linear term. Linear means first power. We have to put that 0 in there. Alright. Now we follow. Every time, bring down the first one. Multiply, add. Multiply, add. Multiply, add. We got another 0. Alright, this is not my answer. What is the answer? When I plug back in the x's. Okay, so the answer is x squared plus 2x minus 6. So what does it tell me about x plus 3? It is a factor of the dividend. Okay, so I'm changing your assignment a little bit. It's going to be odds 1 through 19. You're practicing 2 different kinds of division. Long division on the top part and synthetic division on the bottom part.